So our mission for today, Sam, in this underfloor heating job is to lay down these boards. This is from the underfloor heating store. These are actually cement boards, so they will spread the heat nicely. You often see these with foil over the top, but you don't need it with these because these boards will absorb the heat, spread it over. But we put a self-leveler over this. That has begun to dust up because people have been walking over it. So I think we're going to have to give the whole lot a really good clean.
Definitely.
I just want to explain one thing about putting these screed boards down. You could be putting them over timber floor, or you could be putting them over concrete, as we are here. Now we've put a self-leveling screed down, which is giving us not quite a billiard table, but fairly flat floor. Now, if you've got that situation, you're not trying to level the boards up or take out any discrepancies, any rock, you don't need to use tile adhesive to stick them down. You could actually just use a bit of PU adhesive along the edges of them, stick them all together, then you've got one floating floor. It really depends on the job and what you want to do. So we're going to use a tile adhesive because we're gluttons for punishment, and a few little rocky bits, and we will just comb that through, but we're not going to put a thick bed on there. We'll try and get it as a fairly tight bed, and we've also got the option of using the PU adhesive around the edges of the board just to hold them together. Okay, Sam, it's time to knock up, and I always think it's important to get the water just about right. They reckon this has got a pot life for 2 hours, this adhesive, so we should be all right. This is a little gizmo I've got to help us. Just drop your bag on top.
Your gear falls in.
Now we've got a drawing here supplied by the underfloor heating store, which is going to give us the pipe run. So here's our manifold, which is in the cupboard over there. So along the edge here, we've got room to take our first circuit up, and it actually tells us how many runs we've got here. We can count the runs, and when we get to that point, we go back to the manifold into the return. So we've got 1, 2, 3, 4 separate circuits here, all going back into that manifold. It actually gives you the flow rate for each circuit, and it also tells you the delta T, which is a posh way of saying the temperature differential between the flow and the return. And what they're looking for here is 11 degrees Celsius on those flow and return. So if we adjust the flow mixer on the top of the manifold, we should end up with that design temperature. So we've got 6 runs here, so that's up, down, up, down, up, down, up, down. So that is where we want to be going back to the manifold on that one. Doesn't seem like an awful lot, but we've got to get all the way back down the edge of the room. So as we get closer to the manifold, the amount of ups and downs we can do will increase. Now there's one other thing. It tells us everything about it. It tells us that it's a proof PEX pipe. It tells us that it will go to a maximum of 95 degrees Celsius, which is a huge amount. It tells us it's 12 mil, and it also says that we've got 77 meters left. So I can see the next one down there says 76. It's all on the drawing, so you wouldn't really need to know that. But if you weren't going with the drawing, then you would know how much pipe you've got left. You just measure back to your manifold and make sure you leave a little bit extra. So I put this manifold on the wall yesterday, and now I've had a change of mind. And I'm going to put this pump and mixing valve over on the left hand side, because behind here is an old lead pipe and a disused stopcock, so I just want to get it clear of there. Now the great thing is that you can configure this however you want. You can have the pipes coming in left or right, from the top or from the bottom, and it's just a simple matter of changing around the connections. So you can configure this simply by taking those out. This is going to go on the pump. The pump goes there. That valve is going to the top of the manifold. That's the flow. This one's going to the bottom. This is the mixing valve, and we blend the cold and the hot together to give us the desired underfloor heating temperature. This is not the room temperature. This is the temperature of the water going through the floor. So that's the reason why we kind of recirculate some of the cold water that's leaving the underfloor heating, that's going back to the boiler. We bleed a little bit of that back into the system so that we cool the water down. And that's important if you've got things like a vinyl, luxury vinyl tile or something like that, or maybe even timber floor, where you don't want that temperature to be too hot. But generally you're not looking to get a very hot temperature in underfloor heating. You don't want to be hopping around like a cat on a hot tin roof. You really just want it to be nice, even, gentle heat. So we'll be able to set that flow temperature in a minute. When you put these fittings in, a lot of people I've seen, they just put paste on them. They've got to put paste on everything. And the problem with putting paste on them is that it ends up in all the flow regulators. Any debris is going to end up there. I would actually like to see a filter on these systems just to keep all the debris out of the underfloor. You can flush it through, so maybe after a year or two you want to get the hose on it and give it a good old flush through, clean it all out. That's fine, but I think the less debris you get in there in the first place, the better. The other thing is, I wouldn't normally use grips on chrome, but it's very difficult. It's not too bad here, but here it's quite hard to get a spanner in. We've got the return from the bottom of the manifold. It's going to actually go through, straight through the middle of that valve down there, and that's where it picks up a little bit of cold water to recirculate around the system. This is the hot coming in here. That's the flow, that's the return, and these two are on the manifold. So this is the flow and return taken from the boiler. It's got the motorized valve to control this circuit separately, and now I've got that connected up. I don't really need to use that. We can leave these isolators off, because everything else we're going to do, we can do, if you like, on the dry side of the system, and then we will fill that separately to get all the air out. So I ran this 22mm pipe in one single length in plastic, so there are no joints. It goes underneath the floor, actually under the screed board as well, because it's not playing any part in actually heating the floor up. Now, I've used compression fittings on here. Some people may wonder why you don't just use push fit, but I prefer a compression fitting on a plastic pipe. If it's hidden away and I'm not sure about it, I haven't got any O-rings there to worry about, it goes straight on. So to give you a re-rounding tool here, if you've cut the pipe, there is a tendency, even with nice sharp cutters, sometimes for it to squash the pipe in. So we just give it a little re-round there, put the nut on, and then this is the fitting that goes on. So we've got an olive, and you'll notice that this olive is split, because that olive, unlike on a copper pipe, isn't actually sealing anything. All it does is mechanically grabs the pipe to stop it slipping out of a fitting. And here is the seal. Now you notice there's a seal on the inside, so the pipe is being sealed on the inside, like so. The olive will then go round and squash the pipe, tighten the pipe around that fitting. So we've got that nicely into the fitting there. Just feel it push up and click in. That seal is now made. Apart from the fact the pipe will pull out, there's no need to tighten it anymore, because it's not actually helping it to seal in there. So that's got it. So when you're putting these pipes into the manifold, it's really nice using the formers. You get a nice tidy bend at the bottom. I see a lot of systems where people don't bother using these, and they just have the pipes coming up out of a screed, and it just isn't a good way to do it. These will give you the perfect radius on the bend and give you a lot of nice tidy pipes at the bottom. When it comes to doing your returns, don't try and force that pipe too tightly into there, because you'll get something looking more like a kink. So what I do is what we call the light bulb, which is that you just bring it out to the edge. You get a nice gentle sweep into the curve, bring it out to the edge again there, and then you've got the best chance. The last thing you want to do is start kinking this pipe.
You're hitting it with a mallet. Just how durable is it?
Well, it's extremely durable. I've seen experiments where they've put 100 degrees, they've put boiling water through it, they've pumped it up to way past its operating pressure, and it's still held. Now, if we look in the pipe itself, you'll see that there's a grey liner, if you like, a grey pipe in there, and that is the oxygen diffusion barrier. In other words, it stops any oxygen being drawn through the pipe walls into the heating system, which sounds incredible, but that can happen. So you have that, what we call a barrier in there, so it's barrier pipe, and then we have some aluminium, and that allows you to bend it and it stays where you put it, which is a tremendous improvement. When I first started working with this stuff, you didn't have that metal layer going through, the aluminium layer going through. The stuff used to spring around, and I remember the first time I used it on an underfloor heating system, and it flicked round and hit me in the nose and took a little lump out of my nose. So it did kind of have a life of its own, whereas this is a lot tamer. So not only is it keeping its shape better with that aluminium in there, but it also means that when you lay it down, it stays where you put it. So you just have to make sure that that is pushed up inside that fitting nicely. Don't try and use the nut to take it up there. The nut should then just go on very, very easily indeed. If it's not seated absolutely properly inside that fitting, then you'll find that it's a struggle to get the nut on. When you're offering a pipe up into position, the place to cut it is so that it's level with the bottom of that fitting. When you put your fitting in, the pipe actually just comes up to there. Now I've got this underfloor heating circuit all connected up, everything's nice, full of water, it's time to do the wiring. Now, when you're adding another motorised valve into a system, you sometimes find there's not enough room. I mean, I could do it, but I just don't like to. So what I'm going to do is I'm going to rewire this whole system, because it's not nice, and I'm going to put it into this Wago box here, which gives us a bit more room. So that's the underfloor heating, that's the whole thing wired back up again. It's a bit of a mess, but hopefully an electrician will come in, he'll inspect this and he'll put the conduit on and everything else. So my bit's done as far as getting this thing up and running so that they've got their heating and hot water back on. Now, you can control the hot water, the radiators and the underfloor heating from the underfloor heating panel. And I would love to have done that, but that would have meant running new cables right through the house. Very difficult route. So all we've done is run from the underfloor heating control panel with a signal down here to the motorised valve, and that will switch the boiler on and off as required. The rest of the system, which is the hot water and the central heating as was, is running out of the programmer. So let me just explain what's going on here, because I've filled the system up with water now. We ran the hose pipes into the system through the top and out to the drain. So I took each circuit and I closed them off, opened them up one by one so that we got all the air out of that circuit. Then I closed that circuit off and I worked my way through the circuits until we were running air free on each one. So having done that, I've got the pressure gauge on here, so I can just isolate the system simply by turning off the valves here, and we can check to see whether there's any pressure drop on this system over several days, and if there isn't, then we know we're home and dry, as it were. But I know it's fine now, so I turn the system back on. Now what's going to happen now is that the hot water is going to come through and it's going to go straight up to the top of the manifold. Now as that water warms up, we don't want it at the same temperature as it's leaving the boiler at. Because we've got radiators in the house, we want the boiler set higher and we want the underfloor heating pipes to be at a lower temperature. So when the flow comes through, we can adjust the temperature on this mixing valve here to give us, we're going to go for about 40 degrees Celsius through the floor. That's the mixed temperature. As the floor warms up, a little bit of the cold water that's returning, or the cooler water that's returning, will be bled back into the manifold, so it'll go round again, mixed with a bit of hot water, and that way you get a perfect temperature, perfect blended temperature on the controls. Now, each one of these is a flow regulator. If you look at the drawing from the underfloor heating store, you identify the circuit and you'll see that it gives you a number, and you simply turn that until you achieve the number on the little red float. The next thing is we want a solenoid valve on each one of these circuits. So at the moment we've got a little cap on there. We take the cap off, we're going to put the solenoid valves on. Now, because we've got 3 circuits coming in here from the orangery, if you like, that's these 3 here, and we've got 1 thermostat in the orangery, those 3 circuits are going to be controlled by the 1 thermostat. So we take the cables for those and we connect them up together. They're all twinned together. So all 3 of those solenoid valves will be controlled by 1 thermostat, and they will open and close together. So you see, you can control all the systems through these solenoid valves, and through the wiring center here we can have 8 different circuits for different parts of the house if we wanted to, but in this case we've got 3 different circuits, so it makes it simple enough. So the cables have already been put through. These are the 3-core and earth cables which go to the thermostats, so I'm going to connect those up now into the wiring center. Now, each one of these solenoids operating a circuit has a little ring that screws on first, and then you put the actuator on the top. Now, if you don't have the actuator activated, i.e. the circuit on and this red top coming out, that's because it's basically released the pressure on this thing here. Now you can see that pushes in. Now, if that's pushed in, you can simply put that on and it clicks into place. If, however, you haven't got this activated and you try to push that onto one of these valves, you'll have the devil's own job doing it, because you're trying to push that pin down there in the middle at the same time as you're trying to click that on. So always just activate the circuits that you want to put the solenoids on. With this circuit switched off here, that's completely isolated, so I can run the hose pipes through, flush out the circuit, get rid of all the air in the circuit. After that, once I disconnect these hose pipes, I turn those drains off, I can open up the system. And now if we want to pressure this system at all, if it starts to lose pressure, that can be done from the boiler end. It doesn't have to be done now from this end. So now it's part of the whole heating system. It will have exactly the same pressure on this gauge, which it's running at 2 bar at the moment, as it has on the main boiler, which is also running at 2 bar. So I've adjusted all the flow rates, everything is working. Each one of these is getting hot now. It's going to take several hours for the heat to get through before you start to feel it. So don't panic if you don't feel heat instantly, because even though this is a low build system, there's a lot of cold ceramic tiles there. The whole thing has to heat up. Once it's heated up, you can more or less leave the controls to do the job. So here we got the controls up the top. They're all working now. All the indicator lights are on. I'm going to put these back on. These are the sort of anti-tamper things that we just pop on the top, and now nobody can come along and adjust those valves. Now that's all done, and I put that cover on, the carpenter's going to come back in here, so you're just going to put a nice neat cover on it, and hopefully nobody will need to get in there. I mean, from year to year you really don't need to do too much work. There's no maintenance or anything like that to be done on it. So long as it's all working, you feel heat in the floor, then there's nothing to worry about. This is one of the thermostats. Basically we've got 3 different thermostats controlling the different zones. Now that doesn't mean that it's controlling the number of pipes, because there are 2 or 3 pipes in each zone. So this will control all the pipes feeding this zone. It's at 23 at the moment. That's the room temperature, and we're just running it high at the moment just to get it going, but you'd probably put that down to 21 or even less if it's a kitchen. So there are two kinds of people in this world, I find: those who understand thermostats and those that don't. And the ones that don't are continuously messing with the thermostat, turning it up and down, whereas what you really should do is just leave the thermostat to do the job it's intended to do. It will sense the temperature, it will switch the underfloor heating on when it's required, and it will switch it off when it's not. Now, you have a night setback temperature on these thermostats, which means that if that temperature in the room drops too low, it will kick in just to maintain that temperature, just to bring it up, so that in the morning when you switch it on, it's not starting from cold. There's already a bit of heat in the floor, the room is at a nice comfortable temperature, so it will just build it up again. And that's the way it works best. You can set those temperatures all through the day. If you go out to work, you can set it to lower down, but you just keep a sort of constant, what we might call a maintenance temperature on the whole system. And that saves you all these fluctuations. A lot of people really like that. You can have a lower level of heat because it's spread out more. So with this particular thermostat, you can control it from the thermostat like all thermostats, or you can control it from the app. Link this up to your phone and you can control it remotely, which is quite handy. So I hope I've covered this in enough detail for you, but if I haven't and you've got any questions, you can put them in the comments below. You can also contact the Underfloor Heating store and they will give you loads of advice and help you choose the system that's right for your house.